Hi, welcome back. This is the tutorial on how to import OpenStreetMap data into Rhino using Elk plugin. So in this session, we will focus on how to create buildings on a city 3D models. So there are two ways to represent the building on Rhino. The first is using three-dimensional information that we have exported from OpenStreetMap website, and the second way is to extrude them with building height data that we can generate. So right now we'll show you how to do the first way. The same as what we were doing with highway and railway. We continue using OpenStreetMap data component, drag it to the canvas, and right click on it to change its name. So I name it into building 1, and also make sure that the feature types is building as well. Then I will connect the location and path to this component, and now we can see in the viewport the plugin has supported to create a 3D model. Just right click on component and choose create 3D buildings. As you can see from the viewport, not all the building footprint had height generated. Some are represented on a flat surface, and it's because OpenStreetMap collects data from online user. So when they draw the building footprints with the height number, it will automatically generate in 3D height, and for order it's just represent in a flat surface. Now to generate the 3D building on Rhino, I go right click on the component, go to bake and select the layer building 1, then group it and enable the grasshopper component. So the model on the viewport will only show the poly surface. When you bake the model directly from this L component, it's also baked not only the poly surface but also the point. So these points are not necessary in your 3D models. Right now I want to delete the points. I go to filter and just tick on the point and untick the others. Now you can drag and delete the points from the viewport. To extrude the flat surface so that we will have a complete 3D models. The grasshoppers allow us to generate building heights from flat surfaces. Right now I drag a new component and change its name to building 2, and make sure that the feature types is building. And I connect the location with 5 paths with this, like the first one. And I turn off the layer of building 1 so we can see the new building clearer. The next step is to connect the cloud point by polyline. And in order to extrude it into 3D models, we will need a surface for the point. To create a surface, type rep and connect it with the polyline. To turn off the points, you just need to turn off the preview in building 2. The next step is to generate the height from these surfaces. We use extrude like other platform, and we will need the Z axis for the vertical extrude direction for the building. Type unique Z and connect it to direction of extrusion, and then connect the surface to the base of extrusion. Now the next step is to have a specific height for your buildings. I'm going to extrude the building to 4 levels. So the building had to be extruded by 12 meters for 4 level buildings. I type 12 and connect it into Z, unit Z. Now we can see all the building extruded to 12 meters, but from the front view, all the buildings are the same height, and it doesn't look realistic for the city 3D models. And now I color it with customer preview and color swatch. So that's a really simple way to extrude building footprint to a specific height. And remember to bake it. Go to bake and choose building 2. Group it. Middle mouse button and select disable. For the next step, I can show you how to create a random height for your 3D buildings. To make it more realistic for the models, copy these components, turn it on and change it to building 3. Also change the color swatch for the new layer. Now disconnect the number 12 by holding Ctrl and drag it from the beginning to the end to disconnect components. Now you only have the flat surface. Now we want to extrude the building into different heights but randomly. Type random, and in this random component we have two important inputs with a range input and seed input. For the range input, I would like to set it from 4 to 20 meters for 1 to 5 levels buildings. And right now we cannot connect two values to range in Grasshopper, so we will need a translate component which allow us to connect the two values to random components. And that would be construct domain. Connect 4 with A and 20 with B. Connect it and then connect it with range. Now the same with seed. Is the random engine that we would take from OpenStreetMap data, and to translate it into seed input we will use listlen. Type listlen. Then connect OpenStreetMap data to listlen and connect it to seed. This allows us to translate the data into numbers. Then I connect the random component to the Z direction of extrusion. Now you can see that we already have a complete lively city models with buildings on different height level. And remember to bake them in Rhino. Choose building 3, group it. Finally, group all the script and disable. And that's all for extracting building data into Rhino. Thank you for watching and see you in the next section.